Everyone, alright?
Yeah.
Okay. So today, look at this.
72 is divisible by 3 and 4.
A number
Times
cubic. What's this?
Cube.
Cubic, yeah? It actually means that A times A times A, okay?
Sure.
A times A times A equals that. Okay, so what's this? What's this number? Think. It's not that hard. Come on. Okay, so here is the pause.
I know
Okay?
this.
For the audience in front of the YouTube, okay?
No. I
Yeah.
noticed 72 is divisible by 3 and 48 is divisible by 3, but that might not help.
Okay, so
We have another thing.
you can work as a group. This is not that hard.
54 is divided by divisible.
Wait.
5
You can use the pen if you want. Come on.
9, 17, 19, 28. It's not divisible by 3.
Do you want me to give you a hint?
I think it's divisible by.
Do you want me to give you a hint?
No.
Okay, come on.
No,
think.
wait, no.
Yeah?
I think A ends with a 1.
How is that possible? 1 times 1 times 1. How is that ending
Oh,
too?
yeah.
Okay, it's
So
not ending.
something times something times something.
Okay.
No, it ends with a 9.
9?
Something times something times something equals 9.
No, that's
It
9.
can't end in a 9.
Okay, so we rule out the 1, right?
Yeah.
Because
Yeah. Let's just do this.
Yeah, rule out the 1. It's not possible. Not 1. Not 1. Not 2. Is it 2? 2, which is 8. No. Okay, so what's
3, 3, 3,
yeah,
which
3.
is 7.
Okay, 4, 4, 4, which is 4, right?
Yeah.
5, 5, 5,
5.
6, 6, 6, which is
6.
7, 7, 7.
1, 3.
Okay, then what's
No,
left?
7 times 49 times 7.
Yeah, it's 3. Okay, and what's the only number that's missing?
8.
Okay, so this A is something ends with A, right? Because A times A times A it ends something with 2, right? Okay? Okay, good. So what's A?
So it means
You don't know, right?
the remainder must be
Wait.
70 something.
Can I give you a hint?
No.
Come on, you need a hint, obviously.
No, we
You're
don't.
not guessing, okay?
We don't.
8 times, wait, what's 8 times 8? Wait, what's 8 times 8 times 8? And then we'll do that.
It's 512. 512.
Mhm.
512.
512. So 512.
How is that possible? So, okay, let me ask you one question. How many digits is this A? How many digits? How many digits?
3.
2.
2 digits, right?
Maybe.
What do you mean maybe? Come on.
Yes!
Is it 1 digit?
No.
No.
Obviously, not 1 digit because the
no.
maximum 1 digit is 9
No.
times 9 times 9. It's less than that, right? Is it 3 digit?
No.
Why? We
Because
can check.
100 times 100 times 100 is very much larger
Yeah?
than
Yeah. Okay. So it must be 2 digit. Okay. So that's good. Very
And
good.
then
Because
we
it's
do
not
it-
1 digit. It's less than 3 digits.
Wait,
So
can we
it's 2
just
digit.
no, can we just do binary search? Like do
Yeah.
the middle of it.
Good job. I was going to talk about that binary search. Okay. BS. Okay. It's BS, not bullshit. Okay. Binary search. Binary search. Okay. So, but before that, something 8. Okay. Yes.
Yes.
That's good. Okay. Can we do binary search, right? Look,
yeah,
look,
we
the
no, we
digit.
don't, no, yeah, we do because we could do we could do
No, I think
what we could do 18, 28, 38, 48, 58, 68, 78, 88 and
What's binary search?
halving it.
Half an
So you
okay,
can do
before that,
so you can do
we talk
58.
about this how many digits. It's actually kind of like binary search, right? We check if it's 1 digit, we check if it's less than 3 digits, then we narrow down it's 2 digits, okay? So now this one,
58. Try 58 times 58 times 58.
I think,
Yeah,
it's, eight,
no,
I think it's 88.
how is that idea? We can check.
So
Come
what's
on,
58 times 58 times
come on, you can
So
add.
what's 58 times 58 times 58?
98.
Let's try. Look, if it's 10, what's the cubit?
If it's cubit
Right? Yeah. If it's 20, what's the cubit?
It's 6,000.
How is it 6,000?
4,000.
Cubic.
1,000.
8,000.
8,000.
Let's go.
Okay, 30.
27,000.
27,000, right?
64,000.
40.
120,000. 225,000.
64,000. Okay, do we need to continue?
No.
So what's the answer? What should I put here?
38.
Good job. Because this one is between, right? Got it? Yeah? Simple. Okay. So this is, very simple. We just look at it. But
That wasn't very ideal.
that wasn't very ideal. I can agree. I agree. That wasn't very ideal. Okay? This is fine. Remember one time you pulled down my laptop.
And headphones.
Yeah. Okay. Yeah, I will kill this one. Yeah, this is integer. This is the cubic. We want to find the cubic root of integer. But suppose your computer, how do you find out this? What kind of solution can we use to find the integer root?
Bruteforce.
Bruteforce. Yes. So how can we Bruteforce? How can we Bruteforce?
Check every possibility.
How many possibilities?
Infinite.
How is the infinity? We given this and how can we know? Suppose this is known x. Come on, Eric. Right. This is x we given, and we only want to find the integer part. Integer, okay? Because it could be a fraction, right? Remember, this 2 to the power of 3 equals 8. But if we say what number to the power of 3 equals 9,
What to the
there's
power?
no integer part because this thing, right? This thing is bigger than 2 to the power of 3 and less than 2 to the power of 4. Am I right? No. Less than 3 to the power of 3. Yeah? Yeah? So it has a fraction part. So this A is 2 point something, right? So but here, let's simplify a little bit. We want to find out the integer root, cubic root. So let's say we given the x integer, and how many? I'm asking you. You say Bruteforce, right? I want to know how many solution we do. How many values of a we need to check if given this number 54872. If you're going for Bruteforce, how many solution we need to check? How many numbers we need to check? How many numbers? We can try with 1, right?
Yeah.
2,
Yeah.
3. How many numbers we need to check? The most stupid way is check up to this number, right? That's Bruteforce, right? But obviously we don't need to check up to that, right? Yeah?
Up to, is it like a quarter or something?
Good point. Okay, good point. Half?
No, I think
It's less than that. It's a lot less than that. Yeah. But this is Bruteforce, right? Linear, right? If you given this n, right? Define fn. We want to find out the integer part. A to the power of 3 equals n. We want to find out if there's an integer part of a. If integer part, which the cubic power is n, right? We can do the Bruteforce, right? For I in range start with 1 up to n, right? And then if I to the power of 3 star 3 equal n, then we return I, right? Otherwise we return -1 or whatever, okay? Bruteforce. The time complexity is O n, right? Linear, okay? How can we make it faster? We talk about
Getting a computer. Getting a calculator.
Yeah, but what's the solution? Look, this is Bruteforce, right? It's slow, right? But do we need to do that? Can we use this BS?
Yep.
How can we use the BS?
In a good way.
How can we binary search this?
Using a method.
Yeah. Why we can use this? Because f
Good.
a this function a to the power 3, this is monotonic. What's monotonic? Monotonic increasing or decreasing?
No, monotonic is when something is the same shade of color.
In math. Monotonic. What's monotonic?
It's like
Down,
one,
going
one.
down, going down, going down.
Because it means like one line.
Is it going down? Is it going down? The same.
No. There are two monotonic increasing. Okay, there are two things, increasing or decreasing.
Yeah.
Increasing is that this function, right? This is x,
Yeah.
this is fx. So the shape is something like that, right? So
That's nothing.
no. Look, this is A. This is B. If A is smaller than B, we know FA is smaller than FB. This is monotonal increasing, right? If A is smaller than B, we know this FA here is smaller than FB, okay? Monotonal increasing. Got it? Monotonal decreasing. On the other hand, what's monotonal decreasing?
It's always going down.
Yes, going down. Okay, so this will be different, right? A is smaller than B, then FA bigger than FB, okay? You can put an equal sign here, it doesn't matter. Okay, and how about this one? How about this shape? Is this monotonal increasing or decreasing? This is
Neither.
no, neither, right? Because this is going down, this is going up, right? This is kind of like shape FA equals A squared, right? So it's not, okay? This is math. So we can apply the binary search on this monotonal function, right? The monotonal function. So how can we put binary search this? Simple, right? We check the left boundary, okay? Remember, we given this n, right? Okay, right. This n. The left boundary, let's say, is 0. Okay. So which number we need to check? Which number we need to check in the middle? Half, right? Okay, we check this number. This is n, the left plus right divided by 2. Then we check, this is in the middle, right? We check the middle cubic. If this number is smaller than n, because we want to find this, right? We want to find this. We want to find this a, right? And then we check this number. Cubic is smaller than n, so which half I should go? Is it in the left or right?
Is in the left.
Why is it left?
Right.
Why is it right? Come on, you're not guessing. This is 50-50, okay?
No, right. Because,
Right, yes, why?
Because it's cubed.
Yeah. No, look, you have to answer this, okay? So this is 5, 4.
Something cubed must be a positive integer.
Okay, let's
Unless
okay,
it's already
let me try.
negative.
Let me try. If n is 64, okay?
Okay.
64, n is 64.
I don't care.
Okay, now the middle one is 32. 32 times 32 times 32 is bigger than 64, obviously, right? So which part? Should I go left or right? The number,
Left.
obviously, yeah, it's left. And then now I go to 16. 16 times 16 times 16.
But
Yeah?
the problem is that if you go down by half, then it's always going to be on the left.
No, it could be on the right.
No.
Okay, let's try. 16 times 16 times 16 is bigger, right?
No, I'm not going to say at the beginning it's always going to be on the left.
Very good. Yes, you raised a very good point. Yes, because why? Because we pick this n, right? But imagine, okay, I was going to bring it that if a to the power of 3 equals n, if n is bigger than 1, okay, bigger than, okay, if n is 0, okay, can we get something? If n is 0, what's a?
Yeah, but
What's a? What number times 3 equals 0?
0.
Yeah, if n equals 0, then obviously a equals 0, okay?
But half of 0 is 0.
Huh? That's obviously. So
No.
there's a boundary issue here.
You can't divide by 2.
Well, can we divide by 2? No, I'm just asking. If n is 0, then a is 0. You know that, right? If n equals 1, what's the answer? What's the answer? What number times 3? 3 times equals 1.
1.
Yeah. Okay. Now, interesting now. If n is bigger than 1, right? If a is bigger than 1, if n is bigger than 1, this a will be smaller than n. Okay? But if n is smaller than 1, bigger than 0, right? If n is smaller than 1, then bigger than 0. A is bigger than n. Okay? A is bigger than n. Here. But if n is bigger than 1, then a will be smaller than n. Okay? It depends on this n. Do you get it? Look, if n, let's try this one, okay? If n is 1 over 8, 1 over 8, right? Then if we do the Rubik cube here, this will become the cubic root, okay? Which is this one. Okay, so this half
What?
is bigger than n. You see? If n is 1 over 8, okay, then because what? Half times half times half. This is 1 over 8, right? Look, if this number is smaller than 1, bigger than 0, then this root, the solution is bigger than that, right? Yeah. But if it's bigger than 1, for example, n equals 64, then the a is 4, right? 4 times 4 times 4 is 64. A is smaller than n, okay? You see the difference is between these two cases. Okay. How about if the number is negative? Minus 64.
Then you can like ignore the negative and then put the negative to the answer.
Well done. So what's this?
-4.
Well done. You will take off the negative, which is 4, and we'll put the negative there, right? Good job. So yes. So now this number, right? We cover all the cases. All the negative we can convert it to positive. And then here this is 1. And we know that 0, 1, right? We know this bit and we know this bit, okay? So you were saying that point, which is that why every time is smaller, right? Yeah? Because
No, I'm not saying why everything's small.
Yeah.
Why it's always smaller. I'm just saying that you don't have to do half. You only need to do quarter.
Why is it quarter? It's a method.
But-
Actually, I'm not quite sure
No,
about
because
that.
the minimum is 2 cubed and 2 is a quarter of 8.
Well done. Okay. So you're positive integer. Yeah, we're finding the root, right? Positive integer. Okay. So
Unless it's like, I don't know, decimal.
fraction. If it's fraction, I was covering the whole cases. If it's not just the integer part, right? If the integer part, we can brute force, right? Because why? If we want to find out the real root, we can't brute force. Okay. So how can if we want to say a to the power of 3 equals 1, 2, 3, 4, we can't brute force. You know why? Because there is no integer. It doesn't have an integer solution. Okay? Do you get it? We can't brute force each integer. We can only brute force the integer part, right? 1, 2, 3. But if it's a real number, you know the real number, like something like 1.2, 1.3, right? Some numbers, rational numbers, right? Have you learned that at school?
No, I learned it from a book.
Pi, right? The e, right? The natural number e, and then square root of 2, right? This is not a integer part. You know this number? 1.4 something. It never ends, okay? Have you learned the numbers? The integer, right? The fractions. Those numbers which never repeat itself, right? Okay? They're quite complex number, right? Okay, so here we can't use the brute force because the number is not an integer. Okay. What I'm talking about the cases we want to find out the solution. How can we find out the solution? Right? Left to right, left to right. And then if the answer is so close, if let's say we define a very small number which is 0.0000001, okay? Something like a very small number.
Wait, what's 3 squared is what then? What's 3 squared?
3 squared.
Yeah.
This is 9.
No, 3 squared.
You mean like square root?
Square root, like that, right?
Yeah.
This is
two-
1.7 something. We can calculate it
1.7 something converted to a fraction or something.
one easy way, right? Look, square root of 3. The integer part will be 1, right? It's between 1 to 2, right? Because 1 square equals 1. 2 square equals 4, right? It's between these, right?
Yes.
So let's say the fraction is x. 1 plus x square equals 3. Okay, can we do that? Yeah, we want to find out this x, right? It's 1 point something.
Yeah.
So, okay, so then let's unroll this. 1 plus, the a plus b square. This is a square plus b square plus 2ab, right? You know that, right? So 1 plus s square plus 2x equals 3. Okay, so this fraction times fraction is so small, right?
Yeah.
We can now just ignore that. I'm just ignore that for the estimation. So 1 plus 2x equals 3. X equals, this is 2. X equals 1, right? Is it 1? Yeah?
Yeah.
Yeah. 2x equals 2. X equals 1.
Are you sure? You know what you're doing. Wait, can I see the answer? Like, can I see like 1 point? Does this work? Like, like in between?
Yeah, in between.
In between the 3. Yeah.
Yeah.
And it's the second one of the second interval of the 3. So 2/3 is 0.75. So isn't it kind of like that?
Okay, I kind of, your estimation x equals 1, so that's still right, because x equals 1, we plug in is 2, right? So it means that we still need to do that, so which is 2 plus x squared equals 3. So let's keep going this. 4 plus x squared plus 4x equals 3. So we drop this for now. So 4x equals minus 1, right? So x equals minus a quarter. And then we keep plugging this value back. Okay, do you get it? We keep plugging this value back and do this equation. Yeah? This can actually work. Yeah, x equals 1, but it's not accurate enough. We need to get this value because it means that the initial guess is not very accurate. Okay, so that's why we need to amend the value. Okay? Yeah? Does it make sense? Okay, we talk about that. This is a side topic. Okay, so here the binary search. How can we do the binary search? We specify the left, we specify the right, and we get the middle, and we check the middle to the power of 3. Right? We check the middle to the power of 3. If the difference is so small compared to that is minus this n is so small, then we get the answer. Otherwise, we check if it's on the left side or right side. And we keep this repeating, right? This function is monotonal increasing or decreasing. It's increasing actually because we convert the negative case to the positive, okay? Does it make sense? Okay, let me write the code. Define fn, okay? We check the cases, right? If n equal 0, return 0. There's no point to continue. If n equal 1, return 1, right? Yeah? If n is smaller than 0, then we return what? Minus f minus n, right? We convert the negative case to the positive case, right? Alright, does it make sense?
Sure.
Yeah? And how about now? Now we need to check, right? The left equals, come on. The left equals 0, the right equals maximum of 1 and to the power to the n. Why? Because, yeah, this is a special case. Everyone, come on, can you sit down? Otherwise I can talk. The right here, right is very special because remember we talk about this. This 0 and 1. If it's here, then if we set the boundary, here, we may not find a solution. That's why we need to extend our right boundary in case of this n is between 0 and 1. Okay? And then now we can do this, right? Why what? Why this answer, right? We can do this. Why L smaller than R, right? Smaller or equal than R. The middle equals the left plus right divided by 2. And if the middle square, m3 equals m times n times n to the cube of 3. Then we check if the difference ABS m3 minus n is so small than this number, right? This 0.001, then we return the middle. Otherwise, we check, right? If m3 is smaller than n, we go on which side? Here, this is m, this is n, this is L, this is R, okay? If this to the power of 3 is smaller than n, if this number to the power of 3 is smaller than n, we need to go on the right side, right?
Yeah, but that will never happen.
I know, but sometimes you will have, yeah. Then we need to go on the right side, so which is right side, which is the left equals middle. Okay, otherwise the right equals middle, alright? Yeah? This is binary search. Okay? Does it make sense, yeah? Okay, that's it for today. Bye bye. Bye.
Let's go.